I developed a little script to get these values. This is a Python script that lets me get the values of the stresses, and not one by one, but all of the contact stresses that we need. So in here, it is divided by some sections. First of all, we have to define the database that we're going to work on. Normally, this is going to be called ODB, and it is called like this. The only thing that you have to change is the name of the ODB, depending on the ODB that you're going to work with. Then here, I have developed another object called contact. This contact object is going to help me just get the values of the contact region, the contact set that I created. How do I know that it is the contact set that I created? Well, because I told it to go to the instance called plane. Normally, it doesn't matter the name that you have for your instance. It is always going to be the instance on uppercase and normally like a 1. And then you put element set and the name of the set on uppercase. Then in here, what I'm telling the code is to get the values of stresses. For example, here on the last frame, or well, the last increment of the max step, another one that goes to the last increment of the contact step, and another one that goes to the last increment of the max step but gets the field output of the coordinates, because we need the coordinates to do the graphs. So these first ones are for stresses and this last one is for coordinates. And lastly, we have to get the stresses, or well, get these field outputs and get the subset of the contact region, or well, the region that we want. And this zip is just going to be to do all the force for these three variables at the same time. Okay. And it is always going to be like this. It is going to be the name of the variable dot values. So in here, for example, for the stresses, or well, normally for a field output, you're going to have the value or the variable where you have the field output dot data, and then depending on the data that you want, you're going to put a number. So for example, for S11, or well, the stress on the x-axis, it is going to be the 0. Finally, I have this here, like for example, if you want to get all these values inside a .txt file, you can use the open. For example, in this case, I gave it the name s11.txt in the write mode. And in here, what I did was just tell it, write what is inside of I, that I is the s11, that is the values that we have. Map them as a string because they are numbers, and for .txt files to work, we need to work with strings and join them with a tab. And just at the end, do an end line. And I do it for S11, S12, and S22. I go back to Abaqus. If I press here, you can see that there is a kernel command line interface. This is where you can place your codes. So if I do Control B, it just did all the code. And if I go to the temp, that is where I have saved this database, you can see that I have my files, my S11, where I have the coordinate and the value, the S12, and the S22, all in order. And if you place this rather on Excel or, for example, in Python to graph, you're going to get these results. These are the results these are the same results that you saw there on those text files. So as you can see, the shapes are very similar of the theoretical ones that we saw on the introduction, but we need a way to verify them. So I'm going to verify them with the theoretical ones. So first of all, in this figure, we compare the S22. As you can see, the predicted line and the theoretical one are very similar. The maximum theoretical pressure is of 186.98 megapascal, and the predicted one was 187.38 megapascal, with a relative error of 0.21%. Quite well. Then, for the tangential load, the tangential stress, it is a little bit different. There are some differences here on the maximum values. For example, for the maximum value, the theoretical one was around 102 megapascal, and the one predicted was of 95 megapascal, with a relative error of 6.7%, which isn't the best, but you can go on and do smaller elements. It works. And lastly, for the tensile stress, we go only for the max value, where the theoretical one was 261 megapascal and the predicted one was of 252 megapascal, with a relative error of 3.59%, which is relatively similar. We can say that the verification was okay. And with this, we end workshop 1.